Yeah, g'day YouTubers, Tinker O'Toole with another video. In today's session we're going to talk about the Jolly Star, how this grinder is much better than the Jolly Evo. I got the Jolly Evo, so I'm just going to talk about this. Someone I know was thinking of buying it. I told him to buy this one rather than the Jolly Evo for a few reasons. One of the reasons that I don't like the Jolly Evo is that when you adjust the head, they've got a screw mounted on the back and that controls the height of the head. I really dislike that because you're pulling this down and you've got to try and fit your fingers in there. Having this piece of metal mounted here with a screw on here is much, much better. Just about every decent grinder mounts them in that position. Same as the STIHL USG grinder has that type of mounting mechanism as well. So that's definitely a feature that I like. One of the other features that I really like about this grinder is this handle mechanism, this whole mechanism here. All right, and I will go over this in a minute. But another mechanism that I really like is that if you're doing 10 degrees downward tilt, this is set up much better than a lot of other grinders. What I'd like to show you is, if you have a look where it's got zero angle, you've got this face here that you line up with the black marks, then you've got this face in there that's about another 1.5 millimeters. So you've got this face and this face. So as you can see, 10 degrees down and zero angle. When you use 10 degrees downward tilt, you lose 2.5 degrees off the top plate. So on the movable head, you lose 2.5 degrees. You'll lose 2.5 degrees on the top plate angle as well. And we'll see whether you can see that. We'll need to adjust. Okay, what I'd like to draw your attention to is you've got 2.5 degrees offset here. This is the zero mark that you use, but when you use 10 degrees downward tilt, you can see this little notch here on the left and on the right. That notch is 2.5 degrees offset. So you lose 2.5 degrees on the top plate as well. So 2.5 degrees off the top plate cutting angle, and 2.5 degrees here when you do 10 degrees downward tilt. So that's that feature. The other feature that's actually brilliant is this type of mechanism on the clamp is a little bit different than a lot of the other grinders out there. It has a worm drive in here, self-centering vise. With a little bit of movement, they open and close. But if you look at this side of the clamp, it pivots a little bit and it doesn't go the full length. It only goes partially and has these large discs on springs. So you can put harvester chain on this. It's got a large radius on here. And if we come around here, we can demonstrate how accurate this is in opening and closing, right? So that's in the closed position. It's probably about 0.5 mil. And in the open position, it's probably about 5 millimeters. So you could put your 2 mil harvester chain through that without any problems whatsoever. And if you, before I mention about how this moves like that, so this will push up evenly with very little force and lock the chain into position with very little movement. Plus the other thing is, it depends whether you're a left-hander or a right-hander. If you hold your thumb on the button and pull this forwards, the handle, you can tilt this to any operating position 360 that you desire. Now, a lot of people talk about the hydraulic assist. With this type of grinder, to me, I really honestly can't see the reason why you'd want hydraulic assist on this. And I'll demonstrate why. The only thing that I've got against hydraulic assist is that I've heard off a few people that they leak on them after a bit of use. So I'm not prepared to take the risk. Okay, so if I lock that in a position, I've adjusted the handle, right, in that position. So that's my position that I like, because when I bring my hand in, my hand's on a slight angle. So I like to have that handle. If you put your hand in vertical, you might want the handle facing that way. So I bring my hand in roughly at that angle. So With my right hand, let's say I proceed to grind a tooth. When that tooth is finished, with my left hand, I'll hold it at the back of the chain here, right? I'll loosen this and I'll push it forwards. As I pull it back, then I'll just lock it in a position. I've got to put my left hand, there's no such thing as automatic feed. You've got to put your hand in there to push it forwards. No big deal that as soon as you finish grinding, you put your right hand on here, your left hand on here, just lift it up a little bit, lock it in. It really doesn't take any extra time to do that. And as I said, if you don't like it in that position, then just pull it and move it the position that you like. That's why I really like this system. With the cam lock-in system, it always goes backwards and forwards, and you've got to move it a fair distance. So this is why I like this model. This is my preference, and the large discs also mean that the chain rotates. Look how easy it spins around. So easily does it spin around on that. Now, the other thing is, I'm going to talk about Hexa and why I personally like Hexa than any other chain, right? The slowest chain is your semi-chisel. Your full chisel is your next fastest chain. Your Hexa is even faster than standard full chisel, and your square ground is the king of all, which is the fastest, but it's a lot harder to sharpen, and you can't sharpen it on one of these grinders unless you've got a special jig and a lot of mucking around. I don't prefer to muck around, I just prefer to get on with it. And that's why I like Hexa, and I'll explain the difference between Hexa and standard full chisel. Standard full chisel on a lot of chains requires 10 degrees downward tilt. And on this type of grinder, you've got to loosen the knob on the bottom, push it forwards. So that's tilting the vise. It's a extra thing that you must do. Not that it's going to take that long to do it, but nonetheless, you have to do it. Now, on STIHL's Hexa, if you use the grinding wheel correctly, the grinding wheel, the side of the grinding wheel will go up against the top plate cutting angle. It'll be a flat surface. You won't be grinding on the radius, and we can demonstrate that. And this is the reason you don't need 10 degrees downward tilt on Hexa. So that's roughly our Hexa shape. And this is our grinding wheel, right? And if we put the tooth, this is obviously much bigger than it should be for demonstration purposes. The tooth can move across the face of the wheel. No geometry is going to change if it's held dead straight, right? It doesn't change. If we turn the wheel over the other side, we see the center line. The center line means the middle of the grinding wheel. There's your 10 degrees tilt to the left, 10 degrees tilt to the right. What that actually means, that you're using the radius of the wheel and you're grinding on the radius. When you grind on the radius of the wheel, you end up with different angles. When you grind on the flat of the wheel, doesn't matter where you are on the wheel, doesn't change anything. But when you move up the side of the wheel with 10 degrees downward tilt, what that does, you're at a different angle, right? You're not grinding in the middle, you're grinding on the upper side of the wheel. So Hexa comes down like this and uses the flat section of the wheel. The flat section of the wheel, the side plate and the top plate cutting angle are going to be exactly the same, right? On Hexa, it's 25 degrees on a STIHL grinder, a USG grinder, but that's 65 degrees on an Oregon. So if you set this at 65 degrees, the top plate cutting angle, the head, it's going to come past the top plate, continue down the side plate at 65 degree angle, then change to another 60 degree headed in the opposite direction. They have a span of 120 degrees, which is what Hexa is. And then it will change horizontal direction. So you're going to be using half of a hexagonal profile. You use the side of the wheel, the left side angling at 60 degrees, The right side is another 60 degrees. We'll actually zoom in and we'll show you what we mean about that. Okay, so this is a standard pink aluminium oxide wheel that we dress 60 degrees from this side and 60 degrees from that side. So you've got 60 degrees here, 60 degrees there. That's 120 degrees there and another 60 degrees on the side wheel. Half a hexa. And if we tilt it over into the 65 degree position, we are grinding hexagonal, and we're using the side of the wheel that's going to grind the top plate cutting angle, the beveled edge, right? This is, we'll bring this up. We're going to grind this beveled angle here, dead flat from this side to that side. It's going to be on the side of the wheel like that, right? And it's going to come down like that. So if we put a picture up of STIHL Hexa, right, just try and visualise what we'll do. You've got to visualise this angle, right? There's your Hexa wheel there. There's your angle coming down on your side plate. There's your other angle going the other way. This is your angle that's sitting close enough to horizontal on the bottom, right? They're your three angles, right? The most important angle is this one here. So if we put a picture of STIHL Hexa, you're going to see that hexagonal grind, and you'll see that the side of the wheel goes past the top plate thickness. It comes 2/3 of the way down the side plate, changes direction, goes right down to the bottom of the gullet, then goes across horizontal again. That is it. There's no offset grinding, right? And that's why you don't need 10 degrees downward tilt on Hexa, right? Simple as that. You don't need it. Can you apply this same principle to standard full chisel? The answer is yes, and the answer is they're already doing that with a lot of the teeth. An example is if I put STIHL's RS up, and we'll put a picture up of that, you can clearly see that the top plate cutting angle has a straight section on it and then changes direction about midway on the tooth, which is almost vertical. I think it's about 85 degrees. Looks like a lowercase r, right? So that's pretty easy to do that on a grinding wheel as well. You'll be using the side of the grinding wheel just past the thickness of the top plate. Now, if you're grinding just the top plate on the side of the wheel, it's uniform. You should not need 10 degrees downward tilt. There should be no reason for it. If you are grinding on the side, right, you go a little bit thicker than the top plate. You could be about 1.5 mils. Now, if you're grinding 1.5 mils from the point of the tooth down to the just below the top plate, you don't need 10 degrees downward tilt. It's flat, it's uniform. What can happen, if we look at the radius of a normal wheel, you could be grinding on the radius, or you could be grinding right on that edge there, right? It depends on how you ground the wheel in the first place. And I can demonstrate how that is done and how people can make a lot of mistakes when they're dressing the wheel. Now, if you've got a grinder, it should have came with a radius card. And the radius card should look like this, right? So that's a radius card. Whole idea is that you put it in there and you dress the wheel according to the radius. That's how it's recommended to do. And you're going to end up with a grinding wheel that looks a little bit like this. Half a circle, right? Half a circle. However, if you grind off the side of the wheel so that it looks a little bit like RS, you don't need the radius as big. You only need half that type of radius. And by doing this, you'll be grinding at the side of the wheel. If you're grinding at the side of the wheel, right, and there's the tooth, and if we're coming in at this angle and we're grinding at the side, this top plate cutting angle, this beveled angle, will be ground uniform. It should be sharp. It should have the 60-degree top plate cutting angle, 60-degree side plate angle. It should be pointy and razor sharp on the top plate, on the side plate, and the point should be able to, when you touch it with your finger, it should grip your finger. You don't need 10 degrees downward tilt if you're using the side of the wheel, right? If we want to have a look at something that's really aggressive, let's have a look at Husqvarna's X-Cut. We'll put a picture up of that. And you can clearly see that it's following the same principle where the top plate cutting angle continues down the side plate at a fairly sharp angle of 40 degrees on an Oregon grinder. It's listed as 40, I've checked it at 40 degrees, but if you use a file, see, this is a problem with people who use hand files. Hand files can only do a certain amount of profiling of the geometry of the tooth. This is why you use 10 degrees downward tilt, because you can change the geometry. It's the only way that you can change the geometry using 10 degrees downward tilt. But with a grinding wheel, you can use the side of the wheel, you can use the radius of the wheel, or you can use a combination of both. So in other words, the grinder wheel can be ground to just about any profile that you need. And that makes it very versatile. Now, in the case of STIHL's Hexa, I've got a USG grinder and I've got USG grinding wheels, but I wanted to be able to do grinding Hexa on here. Now, there is a worldwide patent on Hexa. I believe it's the working corner that does all the work. The other part down near the gullet is sort of irrelevant. It doesn't really do much. But nonetheless, that's the technology that's still developed. Husqvarna is very similar, just a little bit different, that's all. Both Hexa and the Husqvarna C85 X-Cut has a narrower kerf than a standard chain, right? By about, the chain's about 0.5 millimetre less width, but 0.5 millimetre probably equates to getting close to 8-9% reduction in kerf. And as you reduce the kerf, your cutting speed should increase, less horsepower is required. So we're seeing a lot in technology developed in this sort of area between Hexa and Husqvarna's X-Cut and some of the Oregon as well. That's what I'm seeing that's taken place now, and that's probably the direction it's going to keep on heading, with those little pointy teeth rather than the C-shape. The C-shape is dead as far as grinders are concerned. As far as filing's concerned, it's been done that way since the 60s, right? Using a file, even before the 60s. First chainsaw was invented by STIHL anyway, 1929 I think it was. So they would have been using files back in the day because out in the field, if they were out in the field, had to have one way of sharpening them. I believe they were using scratcher chains, very time consuming in the sharpening of those. So yeah, certainly these days I don't sharpen in the field. I take about 6 chains out there. Okay, final conclusion. If you are grinding, if you're using the side of the wheel to create your profile on full chisel, whether it's X-Cut, whether it's Hexa, or whether you just want to put a little bit of a sharper point on your tooth, using the side of the wheel is going to ensure that your chainsaw tooth, your top plate cutting angle and your side plate angle will be uniform. And by being uniform, you should end up with a very sharp edge on the top plate. By having that sharp edge on the top plate, the sharp edge on the side plate where they intersect at the point, your angle should be at 60 degrees side plate angle That's the general recommended side plate angle for full chisel. Semi-chisel's about 75 degrees. By having a side plate angle, you'll use a STIHL raker gauge tool to check that, which is just one of these. It's got the 60 degrees and the 75 degrees for semi-chisel on there. It's generally accepted worldwide for full chisel that 60 degrees on the side plate, and you can't go wrong. So in the case of STIHL's RS chain, it's around 60 degrees. In the case of Husqvarna, as I said, out of the box, it's about 40 degrees. And I mentioned that to the Husqvarna dealer, and I said to him, how are you supposed to sharpen this, mate, when it's got a 40 degree top plate cutting angle coming in? He said, oh, yeah, you're not going to do it with a file. Normally we profile our grinder. We've got a grinding wheel that we profile. And I just laughed to myself because I thought, yeah, brings me to the point that they're bringing a lot of full chisels out with these fancy little points on them and that, and you can't replicate that with a file. The moment you put a round file through it, you destroy that type of shape. However, having said that, if you profile the grinding wheel, you can duplicate Husqvarna's X-Cut, STIHL's RS, or any other Hexa, any other profile that you can think of. You can use a combination of using the side of the wheel, the radius of the wheel, or a combination of both. So what becomes important, that if you are using the side of the wheel or the radius of the wheel or both, what becomes critical is the depth that you pull the grinding wheel into the tooth. If you pull the grinding wheel too deep into the tooth, you're going to use all of the side of the wheel. If you don't pull it deep enough, then you'll use the radius or whatever profile that you did on the side of the wheel. So what I do to make life easier these days, I just use Hexa. I use the side of the grinding wheel, and that means that my top plate is uniform from the top plate cutting angle to the side plate angle. It is uniform in angle, and it's uniform in sharpness across there. So one thing about angles, if you're 10 degrees difference on one side, the other side, one side will cut different than the other side. But if it's uniform, it should cut evenly. I hope that information helps. It's gone on for quite a while, but I wanted to get that point across between sharpening full chisel, not using 10 degrees downward tilt because you're using the side of the wheel, as what they do in Hexa. Thanks for watching. Bye for now.